All right, 1.3, maximum or minimum of a quadratic function. The optimum value, i.e. the maximum or minimum of a quadratic function, occurs at the vertex of a parabola. Now, it's important to note that the vertex of a quadratic function can be found by, and there are multiple methods of finding. But remember that when we look at a parabola, we look at where the optimal value is, that is, at the vertex. You can find that optimal value. Where is it located? Again, it's located on the vertex. When the graph is opening down or when the graph is opening up, you will always be able to find the vertex of a parabola. Now, how can you find the vertex of a parabola? Well, that is by graphing or completing the square. When we complete this process of completing the square, you can determine the vertex by finding the values of h, which is located next to the x before the square, or k, which is located after the square. hk will indicate the vertex. Something else you will note is that the sign of the coefficient a, so whether it be in completing the square form or standard form, will determine the way the graph opens. And that is going to be an important feature because that will help us determine the max or the min. Now, if a is bigger than 0, we're looking at the a value being positive, we can make a statement that the graph, the parabola, opens upward. And as a result, the vertex has a minimum. So the vertex will be a minimum when the graph opens upward, and that can only happen when the a value is positive. Next, if a is less than 0, that is, if a is negative, then we can make the statement that the parabola opens downward. Based on that the graph opens downward, we can determine that the vertex is a maximum value. So there is a maximum value for that particular parabola. So, graph opening downward, graph opening upward. You can see the arrows are pointing down for downward, up for upward. You can see that when the graph opens down, you will have a maximum. The vertex will represent a maximum. When it opens upward, we can see that the vertex represents a minimum. This is important to note when we need to determine certain values. Now, moving on. In order to be able to find the max or min, oftentimes we have to complete the square. So what we're going to do is we're going to show the long process to be able to complete the square. That is, first step is to take the a value, the 1, also known as the jacket for those of you that understand, and we're going to create a party scene here. We're going to create a party. We're going to call that a value the jacket. We're taking the a, the jacket, off of all the variables because only the variables, not the constant, is allowed to be in this bracket party. So we're going to create a bracket party because we're going to complete the square. That is x squared plus 8x after the 1 has been removed from each of them, and then the minus 1 stays outside. Next step is to invite twins to the party. How do we determine what kind of twins we invite? Well, it's a special type of twins. It is always this number divided by 2 and squared. That's right, this number divided by 2 and squared. So the positive twin and the negative twin are invited. Why are these numbers all of a sudden here? Well, we have to do a plus and a minus because it balances from the previous equation. What else is important is this plus or minus is one of them stays in the party and the other one wants to join the constant at another party. To do that, we remove the minus 16 out. Again, how did we get 16? That is, we took the number 8, which is still here, divided by 2 and squared. This is going to be important when we look at the short form of this. So we invite the positive and the negative, so 2 twins to the party. The minus 16 will leave because he doesn't want to be with his twins friends inside. They want to go outside and go to the movies, for example. So x squared plus 8x plus 16 will stay inside the complete the square party, whereas the minus 16 will join his friend outside. Now, remember that once the minus 16 leaves, the minus 16 has to have their jacket back. So we give back the jacket to the minus 16 and goes along with the constant. The next step is we actually have to complete the perfect square. Here, folks, we factor. When we factor this part of the expression, it will always turn out to be x and then plus, and the number that goes in here is actually this number divided by 2. Not squared, just the number on the inside. The 8 divided by 2 will go here. So it's this number, the middle term, divided by 2. And then we bring the square to the outside. Why is that the case? Because x plus 4 all squared will actually expand if we use FOIL to x squared plus 8x plus 16. So, to get from here to here, we factored from here to here, we got the perfect square. And then on the outside is going to be minus 16 minus 1, which is minus 17. So, what we have done now is completed the square for this particular expression. Now, let's do this in an easier step. That is, let's eliminate some of the process in order to be able to complete the square pretty quickly. So again, we still have to perform the first step. That is, remove the a value from the variable terms. Next step, we're actually going to skip a step and we're going to go straight to the complete the square. That's right, folks. So what we're going to do is take x plus this number divided by 2. That is 4. Bring the square to the outside, so we're completing the square right away. Then we're going to always subtract. Remember, the negative twin was kicked out, so we're always subtracting. What are we subtracting? This number squared times the jacket. The jacket was a 1, so we always multiplying by the a value. So it's the inside number divided by 2 and squared times the a value. And then we have a minus 1. Last step is to put it all together, so we get x plus 4 all squared minus 17. So we combine the like terms here. And this, folks, will be our vertex form. So that's all we had to do to complete the square. Let's practice a few more. How about this one? Why don't you stop let's do this one together, and then we'll try and do one where you have to stop the video. In this case, g at x is equal to negative 3x squared plus 12x minus 5. What we have to do first is remove the jacket. So we take out the negative 3 from all the variables. So we're left with x squared, and then minus 4x, and then minus 5. So we've done this in the first step. The next step, what we have to do is take this piece, now this piece especially, and perform our little bit of magic. That is the negative 3, and then we have x minus this number divided by 2, which is 2 squared, minus, now what's next? That's right, bracket 2 squared multiplied by negative 3. That's right, 2 squared multiplied by negative 3. And then we minus 5. So this is what we had, negative 3 times x minus 2 all squared minus 2 squared times negative 3 minus 5. So g at x equals negative 3, x minus 2 all squared, and then we put this all together. That is plus 12 minus 5, which is plus 7. So we have negative 3, x minus 2 all squared, plus 7. And that, folks, will be the end of completing the square. From there, we could do some other information. So completing the square is the step from moving from standard form to vertex form. Okay, let's try another one. Here's a little harder. Take some time. Try and do this question by yourself. Stop the video now. Hi, welcome back. Well, what we have to do with this, hopefully you completed this properly. That is, remove the jacket, which is what I did, and you have this. Once you remove the jacket, you then take the number that's in here, so it'll become x plus 1/2 all squared. So we divide this number by 2, that's what we did, and move the square to the outside. Then we subtract. What are we subtracting? The number on the inside, which is 1/2, squared, multiplied by the jacket, which is -2/3, so the a value. And then we're going to add 4/3. By doing that, we can now simplify. When we get -2/3 times x plus 1/2 all squared, subtract, and what we find out is the value is going to be, that's right folks, the value will be 3/2. So you can use a calculator to do this, or you can combine it in your head. So this will be 1/4 times -1/4 times -2/3 is plus 2/12, which is plus 1/6, plus 4/3, we end up with 3/2. So we'll have the final form and complete the squares. So it's now in vertex form, and we can determine the vertex when it's in this form. Okay, moving on. Let's look at some word problems. The cost C of x in dollars per hour of running a certain steamboat is modeled by this quadratic function, where x is the speed in kilometers per hour. At what speed should the boat travel to achieve the minimum cost? The key here word, folks, here is the word minimum. Minimum means we're going to need the vertex. To get the vertex, we have to take the equation, lucky for us we're given the equation, and put it into vertex form. So, in order to see the word minimum, you automatically think vertex. That means we're going to have to put this equation into vertex form. That is, C at x is equal to all of this equation, and we have to remove the 1.8, the a value. That must always be removed from the variable, from the terms with the variable. So you have x squared minus 14.4 divided by 1.8 is 8x plus 156.5. C at x equals 1.8 times x minus 4 all squared plus 156.5 minus, now don't forget when you take it on the outside, it's always going to be minus 4 squared times the jacket plus 156.5. And once we do that, what we can do is calculate the value, and we get 1.8 times x minus 4 squared plus 127.70. What does that give us? Well, it's now in vertex form, so we can find the vertex. The vertex is going to be 4 and 127.70. What does that mean? Well, when x equals 4, we will have a minimum cost of 127.70. So the beauty is we need to know what speed should the boat travel. Well, the boat should travel at 4 kilometers per hour. That's our x value. Now, some of you to achieve the minimum cost. Now, some of you are probably going 4 kilometers per hour, but don't forget this is a steamboat, folks. It doesn't move that fast. Okay, let's look at another problem. This problem doesn't have an equation. A bus company has 30,000 passengers daily, each paying a fare of $2. For each 5-cent increase, the company estimates that it will lose 500 passengers per day. What is the maximum revenue? What fare should be charged to maximize the revenue? Well, R at x is equal to the price times the number of items that we sell. So in this case, we have a price of $2. And in that price of $2, we have a ticket sales of 30,000 passengers. So There are 30,000 passengers for $2. If I increase the price of 5 cents, we don't know how many times we're increasing it, but we know that it's going to increase by 5-cent increments. Every time we increase it, we're going to lose something. So it's the idea, folks, that if price goes up, numbers go down. If numbers go up, price goes down. And that's just logical. So we let X represent the number of 5-cent increases so that we know that this X represents how many times we're going to increase the ticket price. The passengers, on the other hand, are going to go down. How much are they going to go down? Well, they're going to go down 500 X number of times. Again, as it increases by 5-cent increases, the number of passengers go down by 500 passengers. So what will happen when we do this? Well, what we can do now is expand this. So note, one more time, we have this problem going on here. A bus company has 30,000 passengers, each paying a fare of $2. Each 5-cent increase, the company estimates that it will lose 500 passengers per day. So we need to know the maximum revenue. To figure out the maximum revenue, we have to be able to take this equation that we're trying to do, find the equation, and find the vertex. It is not in vertex form right now. All right, let's recap again. In this question, with all the things that it's saying, there is no equation listed. We know we need to maximize because it's asking for a maximum, the word maximize. And in this case, that means we need to have an equation. And we will have to find it, either make it in vertex form or put it in vertex form. So what does this question have for us? It has the following. A revenue that it talks about. How is revenue generated? It is generated by having a certain price of something and the number of items that is actually sold. In this case, we have a $2 bus ticket that will generate about 30,000 passengers. When we increase the price, that is add from $2, a 5-cent increase, a certain number of times, so 5-cent increase intervals, our passengers will go down. So we need to make a statement that says, let X represent the number of 5-cent increases. For every increase in price, we will have a decrease in the number of passengers. That is, 500 passengers less each and every single time we increase the price. Now we have an equation, but it is not in the form that we want. So what do we need to do? We need to expand this equation and then put it into vertex form. That's right. Expand the equation, and this is what we're doing here using FOIL. We will expand it, and then we will collect like terms. That is, we will have, in order, negative 25x squared plus 500x plus 60,000. What this is now is this equation is in standard form, so expand it. Once we've expanded it, we can now put it into vertex form. That is, looking at the equation, we will put it into vertex form. To do that, we take this equation and take out the negative 25 from each of the first two variable terms. That's right, take out the negative 25 from the first two variable terms. We end up with this equation. The next step is to take out negative 25, and we have x minus 10 all squared minus 10 squared times negative 25 plus 60,000. What that gives us is now we've remember again how to complete the square. Remove the jacket, the a value. Now we take this number divided by 2, and we bring the square on the outside. Then we always subtract, always, the number on the inside squared, multiplied by negative 25, and add 60,000. What that will give us, once we've done this, is negative 25 times x minus 10 all squared plus, and we simplified this piece right here, 62,500. That is, we can determine the vertex from this equation. The vertex is 10 and 62,500. The 10 represents the x, which is the number of increases. The 62,500 represents the revenue that we were trying to calculate. So we have a certain price, which will be $2 plus 5 cents times 10. So 5 cents times 10 is 50 cents. Add that to $2, we get $2.50. Next, we have a certain revenue. So the maximum revenue will be $62,500 per day when the fare is $2.50. So if they increase 10 5-cent intervals increases, we will have a maximum profit per day or revenue per day of $62,500. The key with a problem like this is that we need to make sure that we find the right equation, do the process in order to be able to solve it, and then don't forget that if we begin on a question with words, we must always end with words. All right, folks, that's the end of the lesson. Have a numerical day.